Welcome. Thanks for coming to the talk on AI-driven network observability and WTF. What does that mean? I am Jeremy Schulman from Major League Baseball. Please keep in mind that I am from Major League Baseball as you watch this presentation, because I'm going to be doing a lot of demos that maybe looks a lot like I work for somebody else, but I don't. I work for Major League Baseball. When I think of, what does AI mean in the space of network observability, we all start from the place of network monitoring. I'm sure all of us have some kind of network monitoring solution. But when we use the terms AI in today's context, these are the things that I think of. Is there a natural language processing interface? Can I communicate to it in a human form, and will it respond to me in a way that makes sense in a human way? Another element that I look for is, and this is very important, is named entity recognition. And what that means is if I'm seeing metrics that are coming into my system that are tagged with a certain attribute or element, and that matches other metrics or logs or events with that same element, how are they correlated? So I'm going to show you a little bit about that. Retrieval augmented generation basically means how can we take data that's live from our network and augment that into the natural language experience. And if you've followed me for a little while, you know that I do a lot of ChatOps for the network. So part of our network observability system interfaces with our ChatOps system. And one of the things that I'd really like to share with you are some really cool dashboards that we built for our observability system. When I first started with monitoring, I always wanted to know what were people building for dashboards and what were they interested in looking for. And so this is kind of a love letter back to myself about some of the dashboards that I wish I could have seen, maybe 3 or 4 years ago. So our general approach, and people have heard me say this before, our general approach to observability has been a buy, borrow, build mantra. We will buy technology when we can. We're very limited in our staff. I run a team of maybe 3 or 4 people. So we can't build everything. We don't want to take everything from open source and try to maintain and support it. We have just got too much going on. But we do borrow from the open source when we can, and we build only when we must. So for our approach, we decided to buy a technology vendor from Selector AI, which I'm going to be showing you a lot about. We've also bought IP Fabric, which does our discovery and deep network analysis. We do use NetBox. I've been a NetBox user probably since Jeremy Stretch invented it. And what we've built is ChatOps. And if there's anything that you see during this presentation that you're interested, want to learn more about, please do come find me after the talk. So this is how we've arranged our stack, if you will. And I'm going to go from left to right here. We have a Selector AI that runs in the cloud because it's a big AI processing machine, and that has to run in a big cloud environment. But we also have software that runs on-prem because that software has to connect to the devices for streaming telemetry and collecting metrics and interfacing with other systems like, say, IP Fabric. We run NetBox in the cloud. We've been running that for, like I said, many, many years. The network bot is a software that we built, so anything in gold here is the software that we've built. The integration tooling, this is really the magic sauce that ties all these systems together. We spent a lot of time writing code that takes data out of IP Fabric and sticking it into NetBox, or taking data out of NetBox and sticking it into Selector AI. So when you build these types of systems, there's a lot of metadata that has to get put into different places. And there's really no one-stop shop for that. That's the DIY part. Of course, we're using Slack and Google Logs for accounting. So when I talk about what is a better microscope, better microscopes are better dashboards. They are systems that you've built that you're looking for something and you want a better way to visualize that something. But really, when I think of AI, I really think of having better doctors. Better doctors take all of the information that's coming in and giving you as near a root cause as possible, right? So if you can't read this, because I can't read from where I sit out there, this basically says a configuration change on this box by this person caused a whole host of issues. And that's the kind of oh crap to all clear kind of experience that we want to get to. When something happens in the network that's like the oh crap moment, how quickly can we dial in and say, okay, we know where to fix the problem, or it's not our problem? So I'm going to jump into a short demo of what this looks like, because sometimes the first question when something goes wrong is, did anybody change anything? Who changed the network? And so if I wanted to know who changed the network in a time period, and you're actually seeing, this is the Selector product and its Copilot, its natural language experience. It's telling me these are the people that have changed the network. And I could click on any one of those people to see details and have this rich user experience. And this is where the RAG aspect comes in. It's taking the natural language processing and then tying it back to dashboards and data that allow you to drill into it. So if I wanted to drill into like, well, what did this guy Anthony do? Maybe we want to drill into, Anthony made some changes and we really want to see what he's doing. We can just ask these questions in a natural language kind of way, and then it's going to pop up, a more perspective on these are the boxes that Anthony changed. And what's happening here is all of our TACACS accounting logs are being consumed by the Selector product. So we get all of the TACACS change control records, we get all of the syslog messages, we're getting all of the events. And so when I look at this pipeline, if you will, on the far left, we have all of those data feeds coming in, and they're being put into this giant data lake, right? That data lake is then being analyzed based on, machine learning and other algorithms that tell us, is this good data, is this bad data? For example, maybe we have a transceiver running too hot, and we see that's an issue. Or maybe we see we're taking interface flaps, and that's an issue. So these become violations, and those violations are then tied together through NER, named entity recognition, and other AI means or ML means, so that they're correlated in a graph dynamically, and that gets you closer to this mean time to insight. Like, what are the events causing this thing to happen? And then, of course, we want to be alerted, on those events when they occur. So inside the product, there's this giant graph of events and alerts, and you can kind of see this tornado of events that have happened. But really, if you focus right down in the central part of that tornado, it was, John made a config change. And as a result of that config change, all these really bad things happen. But because of the NER aspect and the machine learning aspect of what's coming into the system, it can pinpoint that as a central or a vertex of all of these events. So when we use natural language, one of the biggest concerns that we have is, we have to make sure that our data doesn't get out onto the public internet. And so when we were talking with Selector about our technology and the things that we had to have, we said it can't use the internet. So we have all these, all this data coming into the system, and all that system is being analyzed and chewed on, but that's being chewed on in a private instance. So we're not going out to the internet, and it's not our data is not leaking into any of the major LLM systems. And what's interesting about this is that the LLM system itself is contained inside the instance of Selector. And they base that on an open source model. They trained it with English phrases. But what's interesting is they trained it in a way so it takes the natural language processing and it turns it into essentially SQL. And that SQL then goes into the storage layer, pulls out the data from the ingest layer, and then presents it to the user. So our specific information, the entities that are specific to us, they come from NetBox. And so there's an integration between Selector and NetBox so that all of our devices are known, all of our interfaces are known, all of our circuits are known. All of the data that we store in NetBox is brought into the Selector platform as known entities, so that when we ask for certain things in the natural language, the system knows about them. Now, I often wondered, what does an LLM actually do? You hear a lot of buzzword and hype. This is my attempt to explain what an LLM does. We know what a function does. If you're writing a program has a function, the function has arguments, and then you get some output. Well, an LLM works backwards. It says, if you give me an output, I'm going to tell you what the function is, and I'm going to tell you what the arguments are. So my analogy here is if you're making spaghetti, your ingredients are, the spaghetti ingredients. You have a cookbook recipe that tells you how to make spaghetti, and your output is spaghetti, right? An LLM says, I want spaghetti, and it comes out and it says, well, you need these ingredients, and here's the process to make spaghetti, right? So if I translate this back to an observability system, the LLM takes the input, show me the circuit errors at Seattle in the last 2 days, and it returns back, well, I see you want to select a table of data. That table is circuit errors, and then some parameters are like the site is Seattle, and the time window is now minus 48 hours. So that's kind of my very high-level kind of explanation of how LLMs work by going into a RAG environment and pulling out the data from the system. So I've got a couple examples of dashboards that I wanted to showcase, using the natural language. So this one is all about ballpark WAN circuits. We have, I think, 3 ballpark circuits, or 3 circuits at every ballpark, and that's kind of our bread and butter because all of our video traffic for the ball games, well, they run over these large circuits. So if anything goes wrong, people always want to know, hey, show me what's going on with these circuits. And what I'm presented with is almost like a Google Map-like experience. I asked a question in natural language, and it gave me a widget that I could literally click into and explore, much like you could explore through Google Maps. But if I want to get more specific, I can say, well, what happened over the last 2 days? And what we're seeing is this kind of wheel of information where green is good, yellow is not so good, and red is downright bad. And I wanted to have an ability to filter it out and just show, the not so good and the bad. And you can see as I'm moving my mouse over there, I could click into any one of those elements. But if I didn't want to navigate, through these various steps, I could just ask the basic question, what's going on in Seattle, over the last couple of days? And it would take me right to, a perspective of just the Seattle circuits. So one of the challenges with building a monitoring system is you've got hundreds and hundreds of dashboards, and you kind of lose yourself in all of these dashboards. We wanted a system that we could just say, this is the information that I want, give me, the heads-up view of it, and then let me drill into further information. And here we can see, in this particular case, we had an interface go up and down over a period of an hour in the middle of the night. Not so big deal, right? So that's what I mean by NLP, NER, and RAG all working together. Another thing that we stress out about a lot is interface errors. Interface errors are the bane of our existence when it comes to gray failures. Like interface errors will take down a protocol, and then you've lost your circuit. So again, somebody might be wondering, how quickly can I figure out, are there interface errors going on in our system? Now we've got dashboards that show interface errors, and you can click on it and you see these giant honeycombs of 30 devices, but nobody really wants to navigate that data. We just want to click right into it, and then what we can see from this dashboard is there's a yellow marker. It says interface input errors, if you can see that on the screen, and that's going to take us right to the panel that shows us when interface errors occurred and when they stopped. So I always talk about this experience of, oh crap to all clear. How quickly can we go from, oh crap, something's wrong, is it interface errors, to, okay, it was, but it stopped. Now we've been using ChatOps for a really long time. This is one of the major ways in which teams outside of the network use and interact with the network. So like the previous speaker, they said they built a system that allows somebody to bounce a port, and that takes the burden off the networking team, and it gives it a self-service experience. We use this hand in glove with our observability platform. And again, the bot itself is written in Python, talks to Slack. If anybody's interested in writing Slack bots or ChatOps systems, that's my jam, so please come find me. You can see the systems that we integrate, the networking systems that we integrate are on the left. And then on the right, obviously we talk to Slack because that's the way things happen. We use Okta to do fine-grained role-based access controls. So when you have an app in Slack, by definition, anybody can use it. But you don't want just anybody in your organization bouncing a port. So we've used Okta, and other systems like Okta will do the same thing, is you can define groups of people that have certain roles and responsibilities, and that maps right into Slack using a protocol called SCIM. So if that's something that you're wondering, like, well, how do you make sure somebody doesn't do something? We use the SCIM protocol for that interaction. So bounce port is apparently everybody's favorite. So I wanted to show the example of bounce port. In this particular example of our ChatOps system, we had a very button and menu-driven mechanism. So these drop-downs that you're seeing here are coming from NetBox in real time. So we would pick a ballpark. It would go to NetBox and say, what are your locations for that site? And then from that site, it would tell us these are the phones that you could pick from. And then you have a little menu where you can say, I want to bounce this port, or maybe do other things. And then once they click bounce port, it's going to tell the user, hey, this is what we're doing. It puts it into a thread. Other people can see what's going on. They can see, like, Jeremy bounced a port at the New York Mets. Maybe that wasn't a good idea. But you can see how quickly the reaction and experience works in a ChatOps system. People love the ChatOps. And I wanted to take a minute to kind of show how that is back-ended in NetBox, because without NetBox, we wouldn't have the rich context information. We wouldn't know what sites we have, what locations are involved. So here we can see these are the locations for a given site. And this is where that drop-down payload comes from. We just pull it in real time over the API and then build the drop-down in Slack. And then within a given location, we can see we've got devices. And these are the devices that are in that location. We've got the phones. So if I pick a particular phone, and we were putting phones and other elements that are not networking into NetBox so that we can cable them together. So here you can see that this PoE is cabled to a particular switch and interface. And that's how we know which port to bounce. So I wanted to kind of finish up with some dashboards that I thought were really, really interesting. MLB has an API called Stats API where you can get information about games, who's playing, the players that are up. We integrated Stats API to know which games were happening on which days, so we could get a heads-up view that on this day, this is what's going on at a ballpark. And we can see really quickly all the sites for this day, is it green or not? And if there's any anomalies, we can kind of click into it really quickly and see, do we need to take action? And here, these are transit interfaces. These are something that we would want to pay attention to. Like we would go and check to see what's going on. And then we have another panel of all about our uplink ports and what might be going wrong with some of them. And each of these red blocks show you the KPIs that are in error, whether it's CRC errors or interface errors. You can see that we have all of the syslogs that are happening in context at that time, as well as all the TACACS commands that were done in this window of time. So we can really quickly get a sense of who's doing what and what is happening in our network on a game day basis. We care a lot about our circuits. So we want to know every circuit provider and how are they doing. So this is a dashboard that will show us our uptime for a circuit provider over the course of a given time period. And all of the circuit information has been sucked in from NetBox. So we've got a continuous polling mechanism between Selector and NetBox, pulling in these are our circuits and who are the vendors and the providers of those circuits. We can go into any one of these circuits, and I picked a bad one just to show you that this particular one was having receive power errors. And you can see very quickly there's an issue here on the receive power, and as a result of the receive power being a problem, we're going to be losing our BGP sessions, which is shown right below that. So the idea is to put together dashboards that show context information of the physical layer and the service layer together at the same time. And then we can drill in further to see, what the up-down experience looks like, so that we can determine whether or not, like, should we go back to the provider and say, hey, you guys have been giving us, a bad circuit, or is it our transceiver that's getting too hot and flaking out? This is a case, again, we pay a lot of attention to our circuits, and we want to know, does every ballpark have all of their circuits up or not? And so what this is showing that all the circuits are fine in the last 30 minutes. But let's say we want to look back in time a little bit, and we want to see how things were looking a couple of days ago. Maybe we're doing a retrospective. So we're going to pick, I think, maybe 2 days ago. And here we can see that some of our sites had some issues, but we still had connectivity because we have redundant links. And so if we wanted to jump into any given site, we could go in and then drill into, oh, I see we were getting interface flaps. And those are the events that are registered alongside with the fact that our BGP session for a particular vendor, in this case it was a circuit, and that circuit information is in this interface description. That interface description, that is information that came out of NetBox, right? So that's how we're tying our circuits together with the interfaces, and those metrics are being combined with that NER, that named entity recognition, connecting these two events together. But let's say we didn't want to jump through all these dashboards. Maybe I just want to say, hey, I know what the circuit ID is. Somebody said, hey, can you check the circuit ID? I just say, jump to this circuit ID. Now, in this case, I said, oh, the circuit ID right now seems to be fine. But if I wanted to look at what did that circuit ID look like a couple of days ago, we can jump back and say, in the last couple of days. And it's going to then show me a different perspective. The same information, just with the data showing me the last 2 days, at which point I can then jump into that data. I got to take a breath. We spent a lot of time building and curating these dashboards so that we could have a natural language experience. I'll talk a little bit more about that. Again, we're looking at interface errors here. And what's really interesting is we wanted to look at the optics and look at the value of the optics relative to the thresholds. And that is, I think, on this one, or it might be the next demo. But we're always very cognizant of the optics and their thresholds because we have high-speed tracking cameras that are out there when you watch the game of baseball and you see these slow motion actions or all of the video that's happening over these really high-speed cameras. And when the optic levels drop below their thresholds, that's when we get these intermittent errors. And that's when we have to really be on top of things. So this is the last demo. This is showing a dashboard that's going to really drill into the optics. This was one of the first primary use cases that we had to solve for. In the panel, this is showing you the circuit ID. But in the panel for the receive, what you can see is that it's ordering the values from high critical to where the value is to the low critical. And we can see that the value is under the warning threshold. So we can really clearly see that this is just below the threshold for this transceiver. And this would create an alert in our system. It would tie back into that, what I call that tornado graph, and would tell us, hey, you need to swap out this transceiver. So what's next? What are we doing next? Well, we're all about multicast because our broadcast engineering systems use a protocol or a transport mechanism that's all about multicast. So we need to have really deep and rich multicast tree observability. We want to know receivers to, senders to receivers. We want to know the status of the links that are across those trees, whether those interfaces are taking errors or not. What is the health of the tree across our network? So we're going to be taking advantage of a topology feature and then mapping our KPIs on top of that topology. And when we normally think of topology, we think physical topology, but here we're going to be doing protocol topology. The other thing that we're going to be working on is conversational ChatOps. So you saw the ChatOps system I had with a bunch of buttons. Sometimes we build ChatOps systems that have command words, but people don't necessarily want to remember this is the command syntax for this ChatOps system. They just want to say, hey, I want to bounce a port, on TR01, Ethernet 10, and not have to know how to get to that experience. So we want to provide both not only a conversational experience, but a multilingual experience. We have people that want to ask a question in Spanish, for example. And so we're taking advantage of some technology from Google called Dialogflow that allows us to build systems like that without having to write code. And that's kind of a game changer, so I'm really excited about that. And then finally, something that we have on the horizon is Selector's LLM that's inside their system exposes an API that will allow my ChatOps system to talk to Selector directly. So I can interrogate Selector and say, hey, have there been any CRC errors on this interface? And it would give me back information about that, so I could present that in a Slack panel and a hyperlink to the dashboard. So those are some fun things on the horizon. Things that we've learned over the last year or so building this system. It's really complicated. Like, I don't know, some of you might sat in a session that was like 0 to hero building an observability platform. There's a whole bunch of moving pieces. You have to have a network source of truth or something that's going to give you context so that your interfaces and their tags have meaning, that your circuits have information about them that are meaningful to you. It's a highly customized experience. We wrote a lot of code to coordinate that data between NetBox and, say, Selector, or IP Fabric and NetBox. Now we're starting to see vendors start to build plugins and have a little bit more off-the-truck integration. Seeing more of that would be great. I've talked about a couple of products here, but there's a lot of commercial products. We chose what we chose at the time because it was the best fit for us. But there are many commercial solutions out there. There are many open source options to choose from. I always say do your homework, spend time doing a POC. But once you choose, you're going to get married into that family. Once you start writing to somebody's API, you're in the family, and it's going to be really hard to switch. So it's not impossible, but it's a little challenging. And then, like I said, some assembly is absolutely required. There's not a lot of free lunch in building these systems, so rolling up your sleeves and asking for help, is always a good idea. All right, I've got 2 minutes and 40 seconds for questions. And I will be available after, if people want to come and find me.
Yes, I have one for you. I'm right here.
Oh, okay.
Sorry. So I had noticed that you're doing a lot of, your observability is about the health, and you're looking at your devices. And are you sharing any of your observable events with your service providers?
Not directly. Not directly. The closest that we're getting to is you saw that panel where we're essentially auditing our service providers to ensure that they're meeting their SLAs.
Right.
But we're not making that programmatically accessible to them at this time. It's an interesting question. Why do you ask?
Service provider.
Oh, okay. Then we should talk.
Another question here. With something like ChatOps and giving people power, how do you enforce maintenance windows and ensure they don't break things? Do you queue up the jobs for execution with some guardrails later, or do you just trust they know what they're doing when they're intending to do it?
Yeah, so interesting question. So some of the workflows that are in our ChatOps system, like for the IT team, when they want to change a port, like a desk port to be a printer port or a phone port or something, there's no maintenance window for that action. So there's very curated experiences that we have in ChatOps for that purpose. When it comes to really large kind of project issues, we're Major League Baseball, so we have this thing called the season, which is one big maintenance window, and so we don't really do much. And then there's the off season, which is where we are now, and that's when all of our work is actually getting done. So,
question here. Basically, I have two questions. You mentioned Vector.ai and NetBox, right? Two products. Are you using two products for observability, or one for observability, other for automation? That is my number one question. My second question is, do you also use NetFlow data? Because the circuits are circuit up and down, but major, if something is slow, the biggest challenge troubleshooting the slowness unless you go into the details, what type of traffic you are seeing. And you won't get unless you have net
really
flow,
good,
right?
really good point. So we do have a flow monitoring solution, and what our plan is to do is to not put the flow data into Selector, but when thresholds and events occur in that system, that those become events into Selector so that they can be correlated. My time's up, but please do come find me after the show. I appreciate you guys attending.